Hello, ladies and gentlemen. Welcome to Math 30-3, Chapter 1, Section 5, Scatter Plots and Linear Trends. The outcomes today will be sort a set of scatter plots according to trends represented, linear, nonlinear, or no trend. Solve a contextual problem that requires interpolation or extrapolation of information. And remember, interpolation between data points. Extrapolations beyond. So, match given context with their corresponding graphs and explain the reasoning. And finally, 113, solve a contextual problem that involves the application of a formula for a linear relation. Contextual, context, what's going on? So, it is often useful to draw a graph to help you analyze and understand data. A scatter plot is a type of graph used to discover what relationship, if any, exists between variables. Now, points that represent the data are drawn on a coordinate plane, then the graph is examined to see if a trend or correlation exists. So a trend. You can examine if the points all seem to cluster around a straight line or if they are widely spread out all over the graph. So, trend, straight line. If there appears to be a correlation between the points, you can draw a line of best fit. This is a line that shows the general trend in the data. It does not pass through all the data points, but is instead drawn so that approximately the same number of points appear above and below it. If the point clusters close to the line of best fit, there's a strong correlation. If they are spread farther out, there's a weak correlation. Now, I'm going to skip this vocabulary because I think it's a better idea if we come back and do this after a couple examples. So, now, using a line of best fit, you can find the following information about the relationship between variables. The shape, linear, nonlinear, the strength, weak or strong, the direction, positive or negative, if any outliers exist. Now, for each of the following scattered plots, describe the relation. So here's a plot here. So, is this linear or nonlinear? If it is linear, direct or partial? What's the direction of the correlation, if any? What's the strength of the correlation? Are there any outliers? Sorry. You can get sarcastic. So first things first, is this linear or nonlinear? Well, here I want you to try drawing a line of best fit. So that is a line that goes through most or all the data points. Now, the problem is the line of best fit is an educated guess. And I'm going, yeah, that's what it looks like for me. Now, some of you, now you can look at this and go, oh, but Mr. Sutton, maybe you should go down a little bit here to get some of these dots, and maybe you should go up here to get more of these. So we can argue about it. It's an educated guess. I'm going to guess that because I can. Now, am I right? I don't know. I hope so. So, first things first, is it linear? Well, it definitely looks linear. Now, is it direct or partial? No. That's good, dude. I think, sorry, try that again. Explain, Mr. Sutton, don't blather. Does this look like it goes through the origin? I think it does. Now, once again, that's direct. Partial means it's not going through the origin. Now, so far so good? Sorry about that. Now, what's the direction of the correlation? So, direction of the correlation is strength. Well, this line is going up, positive slope. The strength of the correlation is good strength. That is, the dots are close to the line. There's nothing scattered far away. Now, outliers are dots or data points that are just far away from the graph. They're the what the heck happened here sort of points. Now, let's look at another graph. It'll help. So, here's the second graph. Is this linear or nonlinear? If it's linear, is it direct or partial? Well, here, looking at this, I tend to think it is linear-ish. Now, it's linear, and it is partial variation because it seems to start up here. It's my b value. Now, note, I'm not asking you to come up with the equation. Now, the direction of correlation, this is going down, but more importantly, the strength of correlation, this is poor. It's not that strong because you see all these dots here that aren't real close to the line. Now, outliers. Yes. I think there's two of them. This is an outlier. Something that is really far from the graph. Okay? Now, that's what I mean by an outlier. Okay? So, let's do a couple more of these graphs. Actually, I'm going to pause the recording for a moment. I want you to look at this, and then we'll come back and talk. Now, looking at this mess, I would have to say it's nonlinear, because I can't really see a straight line in there. It looks more like a shotgun blast. So, what's the direction of the correlation? There isn't any. It's not points getting close to a line. It's not points close to a point. It's just scattered everywhere. What is the strength of the correlation? None. Are there any outliers? Yeah, I don't know. But this is just a mess. There's nothing we can say about this. Okay? Now, let's do one more. Now, example D. Is it linear or nonlinear? That you have to be careful about. If you look at it closely, try drawing a line, going, no. Now we can argue about it. Maybe it's a straight line here with some outliers. Maybe. But honestly, the more I look at this, the more I go, curve. So it's nonlinear. So it's not linear, so we don't talk about direct or partial. I think it's nonlinear or curved. What's the direction of the correlation? Well, this is going up, positive. Now, direction of correlation, I should have said that's talking about the slope there. Now, what is the strength of the correlation? I think it's quite good. You look at my crude curved line I drew, there are no outliers. There's only a couple of dots that really aren't, well, even then they're fairly close to the line. So I'm actually happy with that. In a science lab, if you gave me that graph, I'd be very happy, because that's reality. Now, let's go back and talk about these definitions here. Scatter plot, line of best fit, correlation, and outlier. Scatter plot. Now, I need you to put these in your own words. I like thinking scatter plot is like data points plotted on a graph. Now, correlation goes to a line or not. Line of best fit, I think of that is straight or curved line that comes close to most data points. Now, like I said, I want you to put this in your own words. This is just a suggestion for you guys. Now, outlier, change color. This is a data point in the middle of nowhere. Right. It's just going, what the heck? Anyway. So, you know how to do that? And understand those definitions. Okay. So, that's enough for this. So, I'm going to pause the recording. If you have any questions, watch the video. Otherwise, Keep on going. Good luck. Good luck.